We'll go for BCC, body centered cubic. So in BCC, what you find is that apart from the atoms at the corner, the atoms is also occupying at the center of the unit cell. Here at the center, you will be getting an atom at the unit cell. Apart from the atoms at the corner, that means 1 by 8 into 8 plus 1. So number of atoms per unit cell will be 2. Alright, number of atoms per unit cell, it will be 2. Fine. So hence in BCC, what you find is that here we have to first find A cube. That is the most important thing. Otherwise, number of atoms per unit cell is how much? 2. So 2 into 4 by 3 pi r cube. So volume of the atoms per unit cell, you got it, 8 by 3 pi r cube. That is not a difficult thing. Here the most important thing is to find the value of A. How to find it out? So here first I will take triangle ABG. You can see that. So you know that this triangle is 90 degree. This angle is 90 degree. You know that. So in triangle, that is in triangle ABG, as you can see. So what you find is that is AG is equal to root over of AB square plus BG square. And you know that AB, all this are nothing but your A, edge of the unit cell. So it will be what? That is 2A square root over. AG will be 2A square root over. But we are not interested with what you can say AG. That is not our purpose. Our purpose is to find AF, because what I said you, the atom is lying here at the center of the unit cell. Apart from the atoms at the corner, you can see the blue one is the atoms at the corner, and the one which is the center, you will be here. So that will pass through AF, we can say. That will pass through AF. Clear? Fine. So hence AF in triangle, which one will take? AGF. In triangle AGF. Now in AGF, this one is 90 degree. Well, this is 45, this is 45. This is bisection, so it is 90 degree. So what we find, that is AF is equal to root over of, that is AG square. AF is equal to root over AG square plus GF square. So AG square, what will be the root over? Suppose if I do AG I have found it out this. AG square will be what? AG square is nothing but this 2A square. Clear? Okay, AG square will be 2A square, or if I write here AG square, mind it, AG square. AG square will be nothing but AB square plus BG square. That also you can see as you wish. Okay. So AG square will be 2A square. So 2A square plus GF is what? Again same thing, this is A. So it is nothing but A square. So how much we got it? We got it nothing but root 3A square. AF will be root 3A square. Okay. Now AF will be how much? AF will be nothing but again the same thing, 4R. AF will be. Because here an atom will be there, mind it, here an atom will be there, here an atom will be there, and here an atom will be there. Got it? So here R, this R plus R, 2R, and here it will be R, which I have told you in the previous video. Or it will be in the same way, this way, this way. This is your center atom. Got it? This is your center atom. This particular one is the center. Here, this point is your nothing but A, and this point is nothing but is your F. So R, and this will be your 2R, and this will be your R. So it is how much? This is nothing but is your AF. So AF will be your 4. Now you understood? Clear? So this atom is going to touch all the 8 corners. This particular atom will touch all the 8 corners. This atom, mind it, this one, at the center, here, at the center of the unit cell. It's going to touch all the 8 corners. It is difficult to show. For that reason, I have sent you the AV, the previous one, the video I have sent you, the previous one. You have understood it. If you have not understood it, if you have forgotten, once again you see that particular video, you will again understand it. Clear? So in this way, what we can write it here, 4R. 4R is equal to root 3A square. So A is equal to what it will be? That is root 3A square. Now, so we can write it as, if you don't understand, I can write it as A root 3. It's okay now? So A is equal to 4R by root 3. So volume of unit cell, that is A cube. So 4R by root 3 whole cube. 4R by root 3 whole cube. So 4R by root 3 whole cube means 64R cube by 3 root 3. That is the volume of the unit cell you got. I need to rub this part. (64R cube by 3 root 3) got it. Now total volume of atoms. Total volume of atoms per unit cell. It will be 2 into 4 by 3 pi r cube. I said you how it is 2. 2 is nothing but 1 by 8 into 8 plus 1. Isn't it? How do we got 2 here? 2 is nothing but 1 by 8 into 8 plus 1. 2 means number of atoms per unit cell, which is denoted by the letter Z, capital Z, mind it. Clear? So it is 8 by 3. So packing fraction will be how much? 8 by 3 pi r cube divided by, what is that? 64 r cube. 64 r cube by 3 root 3. So I can write it 3 root 3. When I convert it into efficiency, then into 100%. I'll do it. R cube cancel. 8 just 64 cancel. 3 and 3 cancel. You will be getting the answer to be as nothing but 68%. Alright, you will get the answer to be as 68% in this way. So packing efficiency, you got it as 68%. You got it. The packing efficiency to be as. So in this way, we got it for BCC, FCC and SCC. For SCC 52.4, then for BCC 68%, for FCC it is 74%. So the most efficient packing already I said you, that is nothing but is your FCC. So next after that, after doing the packing efficiency or packing fraction, we'll come to that is voids. Voids, we can say that. So we already studied there are two types of voids. When the atoms are arranged in a unit cell, there are two types of void. One is your tetrahedral voids and another is your octahedral voids. Now remember it, tetrahedral means 4 atoms are involved here. Octahedral, 6 atoms are involved here. Octahedral, see, you might be thinking octa means it is 8. No, octagon means it is 8 sides. Octagon. And I am saying octahedral. Octahedral means 6 planes. Find it. Understand the word. I am not talking octa only. Alright, octagon or octahedral. When I say octahedral means it is 6 planes. When I say octagon means it is 8 sides. Don't say sir octa means 8. I know also no, octa means 8. But I am not saying octa only. I am saying octahedral. Alright. So in this way. So hence when 6 atoms are involved here, so we can say it is octahedral. Alright. So when the 6 atoms are arranged, what you can say in this manner. One is this way and another is in this way. Means 3 atoms in this way, right angle triangle. Upright triangle, and the other 3 atoms are arranged in an inverted triangle. So the atoms, the gap which is being created here, you have seen it in the AV. The gap which is being created here, that is called as octahedral voids. We got total how many atoms? 1, 2, 3, 4, 5, 6 atoms are involved here. Alright, similarly, if 4 atoms are involved there, 4 atoms, then it is known as what? Tetrahedral voids. Alright, so this is your tetrahedral and octahedral void, so to say. Now, when you will calculate the radius of the tetrahedral void, because void also some atoms can occupy. Definitely. Voids mean empty space. Why not an atom will occupy there? Definitely an atom. Of course, the atom should be small in size. So, which atom basically occupies? Nitrogen, boron, hydrogen, carbon. So, hence what you find is that here you will be finding it out, that is transition metal atoms, because solids means definitely I am talking about metals. Alright. So, when the transition metal atoms are arranged in this manner, so either the octahedral or the tetrahedral voids are produced. Listen carefully. In that octahedral voids, in that empty space, either hydrogen or nitrogen or boron or carbon is going to occupy the space. That particular space, that voids. And hence you will be getting corresponding hydride if hydrogen is there. If boron, then boride. If nitrogen, nitride. If carbon, carbide. So in this way you will be getting, that is nothing but interstitial, what you can say, there is hydride will be there. Now understood what is interstitial? Interstitial means the vacant space or the empty space. You might have heard the word transition interstitial hydrides. Transition means transition metals. And when hydrogen is occupying the interstitial space, that is known as transition interstitial hydrides. Alright, we are having the transition metals, and in that, it's what you can say, the space which is vacant or empty, hydrogen is occupying that particular space. Then what we say? Transition interstitial hydride. If nitrogen is occupying, transition interstitial nitrides. If boron, transition interstitial borides, because the vacant or the empty space which are being produced, alright, which are being produced due to the arrangement of the metal atoms, alright, is either tetrahedral voids are produced or octahedral voids are produced. Alright, and when nitrogen, hydrogen, boron, carbon are being occupying that particular space, then it forms a compound, and that compound in one word we can say as interstitial compounds. We can say In this way, the interstitial compounds are being formed. But remember it should be a smaller atom because the space is very small. How much it is? We will calculate this one. Now let me tell you, radius of the tetrahedral void is nothing but 0.225 R. 0.225 capital R. Capital R is what? Radius of the atom. Radius of octahedral void is 0.414 into capital R. Got it? Capital R is again the radius of the atom. Whichever atom you have taken it, whichever metal atom you have taken it, the radius of that particular atom. Got it? So almost you can say, almost, listen carefully, almost we can say that octahedral void is almost double that of tetrahedral voids. Octahedral void is almost double that of tetrahedral voids. Listen carefully, octahedral voids is almost double. So generally the cations which will occupy, got it, this tetrahedral voids or the octahedral voids, then what it will be? The radius of the cation. Got it? Listen carefully my word, all the word. Got it? If it's an ionic compound, just now I was talking to you, if it's an ionic compound, then cations and anions will be there. And when the cations will occupy the tetrahedral voids, or the cations will, when it will going to occupy the octahedral voids, then what it will be? That is nothing but R plus is equal to, for tetrahedral voids, how much it is? 0.225 R minus. Or for octahedral voids it will be 0.414 R minus. Here plus is radius of the cation and this is radius of the anion. Got it? R minus stands for the radius of the anion. Now you will say, sir, you said 0.414 capital R. Yes, that also can be. If this is for any compound I said. That is for any other compound. Maybe molecular compound, maybe covalent compound, maybe that is what you can say, this network compound, maybe metallic compound. For that I said. Clear? That also I am coming, don't worry. I'll tell you everything. Now, the question may come into your mind, sir, where have you got this particular formula? Correct. Radius ratio. I'll teach you. Radius ratio is what? Radius of the cation by radius of the anion. Yes, I'm calculating the radius ratio only. Radius ratio. Ratio means I'm comparing it. Yes, what I am doing, I'm comparing. That's tetrahedral void. And to nothing but the radius of the atom I'm comparing, or the radius of the cation I'm comparing, or the radius of the anion I'm comparing. Alright, so radius ratio is what? Radius of the cation by radius of the anion. So radius of the cation is R plus and the radius of the anion is R minus. Alright, so as I said you, if it is for the voids, let us say it is a tetrahedral voids. This radius ratio is for the voids. Mind it. So it will be 0.225. So 0.225 into R minus, R plus. If it is octahedral voids, it will be what? 0.414. Radius ratio will be radius of the void. Again I am saying you voids. I am talking to you. I am talking to here of the voids. The 0.414 into R, what you can say, minus means it is not, minus means it is anion. You can say radius of the anion. Is radius of the cation is this. Alright, from where I got this particular formula? You might be thinking, from where I got this particular formula? R plus is equal to this, R minus R plus is equal to this. How we got it? From here we got it. Radius ratio is equal to radius of the cation by radius of the anion. Radius of the cation is R plus, radius of the anion is R minus. So if it is a tetrahedral void, you will put it 0.225. If it is an octahedral void, you will put it 0.414. Just now I said it. Alright, how it is? I am going to calculate and show it to you. Wait, don't worry. So in this way, you will got it this particular formula. Clear? Now, next I will come to, that is, how did I get this 0.225 and 0.414? Got it? Okay, in the next video. Thank you.